This topic of discussion is meter bridge, and this meter bridge is utilized to determine the unknown resistance, and the experiments are also there to determine the unknown resistance of a given resistor in practicals. Okay, now meter bridge, it works on the principle of piston bridge. Okay, it is an experimental arrangement to determine the unknown resistance. Now see, this is the instrument as such. Okay, this is the instrument which you are using to determine the unknown resistance. Okay, so I am giving you some idea about this instrument. See, here this A to C is a wire which is a manganine or constant wire. Okay, and parallel to it a meter scale is attached. Okay, so if you are say somewhere here, at this point, then the number corresponding to that on the meter scale will give you what is the length of this particular section, and if you take the subtraction of that length from 100, then the remaining length also you can get. Okay, so this is the meter scale which is kept parallel to that wire. Okay, now these are the metal strips. L-shaped metal strip is there. This side also there is a L-shaped metal strip. Okay, this is also a metal strip. Okay, so there is a gap between the first L-shaped metal strip and this rectangular metal strip, and in that gap a resistance R is joined. Okay, a resistance R is joined between these two gap. Okay, rather between this gap. Here also there is one gap. Okay, there also the resistance is joined. Sometimes, rather generally unknown resistance which is to be determined is joined here in this gap. Okay, so this is the practical arrangement. Now there is a contact here at point B. Okay, there the galvanometer is joined. So galvanometer is joined here, and its one end is kept free. So you can move this end on this wire. This is the wire. Okay, the wire which is there, that is AC. On that AC wire you can move this free end. Okay, to get the null point. Now what is null point? Okay, first of all, this is the practical arrangement that you must understand. Okay, galvanometer is kept here. This free end of the galvanometer which you can slide on the AC wire. Now you have to slide this end, which is a free end, on this wire in such a way that the galvanometer shows zero deflection. Now what was the balance condition? Now when we discussed about the balance condition, the ratio R1 upon R2 is equal to R3 upon R4, it should happen. Now see, unknown resistance you can't change. Some resistance you fix here, say whatever value, 10, 12 ohm. So two values are fixed for you. Okay, S, that is unknown, that is fixed only. This you have fixed, say known value, it is known value to you, say 10 ohm, 12 ohm, whatever. And then you are sliding this and getting some point on this wire somewhere here, so that you get zero deflection. Now what happens? This particular point, say here in this figure, the point D is shown as a null point. So this length L1 has certain resistance, and this length 100 minus L1 has some resistance. Okay, say for example, the resistance per unit length of this AC wire, resistance per unit length of this AC wire is RCM. Then resistance of this L1 length wire will be equal to RCM into L1. Similarly, the resistance of this DC wire, that is this part, that will be equal to how much? That resistance will be RCM into 100 minus L1. So try to understand this part. You have fixed this value you want to determine, so that is fixed. Now with the help of this free end of the galvanometer wire, you are sliding that free end on this AC wire, and you are getting the zero deflection of the galvanometer, and this length is L1 this side, the other length is 100 minus L1. Okay, so the resistance of this, say, AD part is RCM into L1, and resistance of this DC part is RCM into 100 minus L1. So you have made an arrangement where you can vary the resistance, that is of this particular section and this particular section. You are varying the resistance by sliding the wire on the 100 centimeter this metal wire. Okay, on this metal wire, when you change the position of this point that is obtained here, the value of resistance gradually changes, that of this side length and this side length. Okay, now we go further. Okay, see, figure shows the meter bridge. R is an unknown resistance. Okay, sometimes R is unknown resistance, sometimes S is kept as unknown resistance. You can shift the R and S if you want to shift. Okay, so R is an unknown resistance whose value we want to determine. It is connected across one of the gap. Across the other gap we connect a standard known resistance S. So this is your standard resistance whose value is known to you. Now one end of the galvanometer is connected to the metallic strip midway between the two gaps at point B, that I have shown you. Okay, at point B, see, midway this is connected. So galvanometer is connected at midway in the middle strip, and one end of this galvanometer is kept free. Okay, between the two gaps at point B, the other end of the galvanometer is connected to a jockey which can slide over wire AC, so that end is free to move. Jockey is a kind of metal strip which can be slided over the wire. Okay, to make the electrical connection. Okay, RCM is the resistance per unit centimeter or per unit length of this wire AC. So RCM is the resistance per unit length. By sliding jockey on wire AC, a point D is so obtained that galvanometer shows the zero deflection. In this condition, the meter bridge is said to be in balance condition. So balance condition is obtained here. AD1 is L1. Okay, the portion AD of the wire has resistance how much now? RCM is the resistance per unit length, and the length of that particular part AD is L1. So the resistance of that section will be RCM into L1. This is L1. Okay, and portion of the other part, that is DC, will have the resistance RCM 100 minus L1. Okay, the four resistance of the bridge are now R, that was kept in the gap, S that is also the resistance which is kept in the gap, and these are the two other resistances, RCM into L1 and RCM into 100 minus L1. Now you take the ratio R upon RCM into L1, okay, S upon RCM into 100 minus L1, okay. So this RCM will be cancelled out, okay. So you will get L1 upon 100 minus L1, and L1 is the length which is practically determined, whatever, say 55 centimeter, whatever it may be, and that value you substitute here, okay. S is known resistance for you, then R the unknown resistance can be found, okay. So unknown resistance R can be found by multiplying this S with L1 upon 100 minus L1, okay. Thank you very much. This is the practical which you are actually performing whenever you are doing the experiment or whenever you will do the experiment, okay. Thank you very much.